Right. This is section 3.3, exercise one. So for each part of this, we're given some information, some properties of a function, and asked to tell whether this function has a global max, global min, neither, both, or do we have enough information to even say so? So function f here is such that f double prime of x is less than 0 for every x. Or, I'm just going to write some equivalent to this here. F is concave down for all x. So what does it mean for a function to be concave down? Well, that means that, metaphorically speaking, the metaphor you're given is that, basically you have a vessel that's going to be spilling water, or you have a function that's going to be whose rate of change is going to always be decreasing. So there are actually a couple ways to look at this. One way you can have a function that's concave down everywhere is that, so bear in mind, they're not saying anything about the first derivative. So it's possible that the first derivative is positive in places. And if that's the case, so why am I saying this function has a positive first derivative? Because there are points here where we have an increase. Oh, that was erasing more than I wanted. So, but there are points here where my tangent lines would be positive. So if you have that case, then you have to have a global maximum. But is it true that you're always going to have that? What if you have a function whose first derivative is, starts off as being negative? And what's going to happen as you move to the right here? That means you have a function that's going to be always decreasing and always at a decreasing rate. What does that mean about whether you have a global maximum? You cannot have one. So let's talk about global maximum. Hopefully I've convinced you that the answer to that is maybe. Because if your function is increasing anywhere, it has to come to a it's going to come to a point where it comes to a global maximum. It's going to come to a peak like this. But it might not. Now let's answer the other one. What about a global minimum? Well, if your function is eventually going to be decreasing, and that decrease, so when I say eventually, so both these functions, the way I've drawn them, there's at some point where everywhere to the right of that point, my function is decreasing. So since that's happening, there's no possible way for me to have a global minimum. I'm just going to keep achieving lower and lower values. Part B, G is a function with two critical numbers, A and B. I'm told that A is lesser than B. Okay, so I think I need to make a sign chart to make sense of all this. So let's make a sign chart. The first derivative. So I know at A and B, my first derivative is equal to 0. What's happening to the left of x equals A? I have negative values. To the right of A, but to the left of B, I have negative values. And to the right of B, I have positive values. Okay. So let's try to draw a graph of what this looks like. Let's assume that A and B are both positive just to make my graph a little easier to think about. So I have a graph that does this. It's decreasing, comes to a critical point, decreases again, comes to a critical point, increases. So what does that mean about global maxes and global mins? So, do I have a global maximum? I think because you have a function that, far like basically have a function that kind of trends upward on both ends here. So you have a function that, for every x value less than a is decreasing, which means the further left I go, the higher the y values have to be. What about as I go to the right of b? Well, since the function is increasing to the right of b, then the further to the right of b I go, the higher the y values get. So because of that, I cannot have a global maximum. I'm just going to keep achieving higher and higher y values. What about a global minimum? Well, if we know that as we go far left and far right, I'm going to be achieving higher and higher values, and I know that at some point, well, specifically at x equals b, that has to be the lowest place my function can achieve. I have to have a global minimum, and it has to take place at x equals b. All right, part C. All right, h is a function with two critical numbers. I'm going to go ahead and do this again. I'm going to come up with I'm going to make a sign chart. So for x values, I'm looking at h prime. Two critical numbers, a and b again. Sounds a lot like last example so far. So 0, 0. For values of x that are less than a, I have a decreasing function. For values of x between a and b, I have an increasing function. And then I go to a decrease. All right. Oh, and also I know something about the limits. Okay, so let's do this again. Let's do this graph a little differently. I'm not told anything about A and B other than the fact that they are A is less than B. So let's do this. I'll say A and B are about symmetric about the y-axis. What's happening at A? I have a function that's decreasing, critical point increasing after. That's a local min or a relative minimum. I have this opposite behavior going on at B, so that's going to be a relative max. And then I'm also told something about the limits. The limit as x approaches infinity of h of x. So I have basically this behavior is happening. So as I get nearer and nearer to the y-axis, I have a horizontal asymptote there. And I also have one, so even though I'm not told this must, actually that can't happen, can it? No, it can't, because then I would have a critical value there. So let me think about this some more. So I have limits, basically I have a horizontal asymptote at the x-axis. But I also know I have to have a relative minimum at x equals a and a relative maximum at x equals b. I think that means then that this relative minimum at a has to happen below the x-axis. And then I have to have this asymptotic behavior. So let me think about that for a second, but I think my logic is good. So I have two critical numbers. I have a relative minimum at A, relative maximum at B, which my sign chart says I have to have a relative max or a relative. And I can't, I believe if on the left-hand side here, are we going to come above the x-axis, I would have to come to a peak, and that would have to be a critical number. So I think I have to avoid coming back to the x-axis again. So I think my graph here is good. So now let's answer the questions. Can I have a global max? Can I have a global min? And I think the answer to both of those has to be yes. Because I think if I respect all these properties, I have to have a global minimum at A, and I have to have a global maximum at B, because I'm not going to be able to have global extremes either on the far left or far right, because I have to be trending towards zero on the far left, on the far right. So I think my global maximum are going to come from my relative maximum. And finally, D is a function differentiable everywhere except at x equals A. Okay, so I have a function. I think I can still make a, let's keep reading. Not differentiable at x equals A. P double prime of x equals 0. Okay, so let's do this. I can make a sign chart for the second derivative, down like kind of partitioned to x equals 0. So basically my function goes from concave up. This is not 0, this is A. And it goes to concave down. Okay. So that's what my function looks like. Let me see if drawing a graph gets us some more insight. So let's say this is A. My function is differentiable everywhere except at x equals A. A function that's concave up. I believe that's concave up. And then it goes to concave down. We also know the function is not differentiable at x equals A. So maybe it looks like this. So maybe it has a hard corner like this. Let's try that again. So it goes concave up everywhere. Am I told this is a critical point? No, I'm not told anything about the first derivative except that it doesn't exist in A. So my function goes from concave up to a corner or a vertical tangent, some kind of non-differentiable point at x equals A, and then I have a function that's concave down. So I think because as I move from left to right, my function, even though I'm not told anything about the first derivative, I think. Well, let's remind ourselves of what the real question is. Do I have a global max? Do I have a global min? I think because this function is concave up everywhere to the left of some point, then as I go further left, I just have to keep achieving higher and higher values. And because it's concave down on the right of this point, I believe I just I think I just have to keep achieving lower and lower values. I think the answer to both of these has to be no. One thing I want to point out there is I believe like at this corner, maybe my function looks like this. If my function does look like that, I think the answer to my question is still the same. I think it's still no on both counts. In this case, I believe I have a relative maximum, but I'm not asked about that. So, but when we're being asked about whether I can have a global max or a global min, I think in this situation I can have, there's no possibility of either one.